Section 6.6, Solving Radical Equations. To begin, let's start with the principle of powers. It reads, for any natural number n, if an equation a equals b is true, then a to the nth power equals b to the nth power is true. So the way we're going to use this is we're going to hold the equality by raising something to a power. Or better yet, raising both sides to a power. All right, let's go ahead and take a look at the first example. We're asked to solve the square root of x minus 3 equals 4. All right, well, we want to solve for x, so our goal is to get the square root of x, or our ultimate goal is to get x by itself. Let's begin by getting that square root of x by itself by moving that 3. So we go ahead and add 3 to both sides. So that we're left with the square root of x is equal to 7. Now our problem is that that square root is enclosing that x. So what can we do to undo that square? Well, we can raise both sides to the second power. Now a square root and a square are mathematical inverses, they're opposites. So we're left with x is equal to 7 squared, and 7 squared is 49. Now, if you like a bit more insight as to how this all works, think of a square root as a rational exponent, x to the 1/2. Now, if we would like to make that x by itself, get rid of that rational exponent, what do I need to multiply 1/2 by so that I can just get x in return, x to the first power? Well, I would have to multiply it by a 2 over 1. This would give us x 2 over 2, which is just x to the first power. So this 2 over 1 is actually just a 2. 2 divided by 1 is 2. So we square it. And that's exactly what we did here. We squared both sides to make it happen. So this is the y, in case you're wondering, like, hey, how does that happen? How is that so? Now, according to our principle of powers, because we have an equal sign in an equation, it holds true if we do it to both sides. So let's take a look here at example 2. We have to be careful because we can result in a false statement. Okay, so let's go through our process. Now I want x by itself, but it's enclosed by that square root. So let's go ahead and square both sides, so that our square and our radical undo each other, and we're left with x is equal to negative 3 squared. X is equal to negative 3 squared is 9. And when we're working with square roots, you have to remember to always check your work, because there will be times when you get solutions that are false. Now, this is our answer, 9. Let's go ahead and check it. Our equation is square root of x is equal to 3, and we found that our answer is 9. Well, I'm sorry, it was a negative 3. The square root of 9, does that equal negative 3? No, right? The square root of 9 is 3, which is not negative 3. So it's not true. So what is your moral of the story? Always check your answers. Always check your answers when you're working with radical equations. That's your moral of the story. Let's do a more complex problem. Now our goal is to get that square root by itself. We first have to isolate that square root. I want to get it by itself. Now here, I have it right here. So in order to get that by itself, I need to go ahead and divide both sides by a 2. Or if you'd like to, what you can also do is, since it's being multiplied, you can just go ahead and square both sides. So that we have x minus 7 squared is equal to, well, 2 squared times the square root of x plus 1 squared. Now they're not being added or subtracted, being multiplied, so the square applies to each one separately. It could apply to each one separately. So now we're left with, on the right hand side, I have 4, and that square root undo each other, so that I have x plus 1. Now on the left hand side, I have to FOIL, or you can go ahead and use your tricks for expanding. So I'll write the notes, the work on the side. So x minus 7 squared, that means x minus 7 times x minus 7. You can go ahead and FOIL, multiply your first, your outer, your inner, your last, or you can remember your expansion rules from chapter 4. So this is x squared minus 14x plus 49. That is our value right here. Okay, next all we have is to solve for x. Okay, we have to distribute in that 4, so that we have 4x plus 4. On the left-hand side, I have x squared minus 14x plus 49. Everything we learned about solving equations always comes back. So in order to solve, remember you first have to set it equal to 0. So let's get 0 on one side. Let's go ahead and subtract 4x to both sides. Subtract 4x, minus 4, minus 4, so that we're left with x squared minus 18x plus 45 is equal to 0. All right, we have a quadratic. Let's try to factor. So what numbers multiply to give you 45 that add to give you negative 18? Well, 15 and 3 work. I need to make a negative. 2 negatives make a positive, and when I add them, you get a negative. Perfect. So this factors to be x minus 15 times x minus 3 is equal to 0. Let's set each one equal to 0, so that I have x minus 15 is equal to 0, and x minus 3 is equal to 0. Let's go ahead and solve. Plus 15 on both sides, you get x is equal to 15. Plus 3 on both sides, we get x is equal to 3. And that's our answer. Now, we have to be careful because we have a radical in our problem. We have to go ahead and check our answers. I'll leave it to you to check it. Once you check it, you'll see that 3 is a false answer and 15 is true. So I invite you to stop your video and go ahead and check it, and you'll see how we just have to be super careful. Let's go ahead and take a look at example 4. It's asking us to solve x is equal to the square root of x plus 7 plus 5. Now what's different here from our last problem, where we can just square both sides, is that plus. That 5 is not being multiplied, it's being added. So I need to get that radical by itself first. So let's go ahead and subtract 5. So we have x minus 5 is equal to the square root of x plus 7. Now we can go ahead and square both sides. And again, the whole purpose of doing this is so I can make that square and that square root undo each other. So that we're left with x minus 5 squared is equal to x plus 7. All right, let's expand that binomial square. Now again, I'll show your work on the side. So we have x minus 5 squared, which means x minus 5 times x minus 5. Okay, let's go ahead and multiply them. Once we multiply them, we'll get x squared minus 10x plus 25. You can get that by multiplying it out or by using our expansion rules that we learned in chapter 4. So that we have x squared minus 10x plus 25 is equal to x plus 7. Now remember, we have to set it equal to 0 before we can try solving. So let's go ahead and move that x. So minus x, minus x, minus 7, minus 7. We're left with x squared minus 11x plus 18 is equal to 0. All right, let's see if we can factor. So what numbers multiply to give you 18, that add to give you negative 11? 9 and 2 look promising. Now I need to add to be a negative and multiply to be positive. So if they're both negative, that will satisfy that. This factors to be x minus 9, x minus 2 is equal to 0. Let's set each one equal to 0. So I have x minus 9 is equal to 0, and x minus 2 is equal to 0. Get x is equal to 9, and x is equal to 2. We got that by adding those numbers. I'm sorry if I skipped a step. So those are our two answers. Now remember, you must check your answers. I'll leave that for you to try. And one of them does end up being false. So look out for that in your homework. Okay, so far we've seen squares. But what about cube roots? Well, the same idea holds. Let's consider what I'm talking about when I say same idea holds. So if I have a cube root of x, that would be the same thing as x to the 1/3 power. If I want to undo that, what would I have to multiply it by so that I can just get x? That would be a 3/1. So that's how we get back down to x. So we can undo a cubic by raising it to the 3rd power. So let's go ahead and do that. Let's take a look at example 5. We have the cube root of 2x plus 1 plus 5 equals 0. Let's go ahead and get that radical by itself because we have that 5 that's being added. So we have minus 5, minus 5. We're left with the cube root of 2x plus 1 is equal to negative 5. Now, here is our punchline for this section. To undo that cubic, let's raise it to the 3rd power. Now, that 3rd power and that cubic undo each other, and we're left with 2x plus 1 is equal to negative 125. Let's go ahead and solve for x. Minus 1, minus 1. You get 2x is equal to negative 124, and we divide by 2, so that we get x is equal to, oh, I added wrong. Negative 125 minus 1 is negative 126. So we're left with x is equal to negative 63. And again, give yourself some space so you can go ahead and check out your work. See if it holds true. Here are some steps to help you to solve radical equations. To solve radical equations, isolate one of the radical terms. Use the principle of powers. 3. If a radical remains, perform steps 1 and 2 again. Check solutions. Check possible solutions. Because remember, we could get some solutions that do not hold true. All right, let's go ahead and do this problem. So we want to solve for a radical, but we see that we have two radicals. Now our first step says to isolate one of them. It doesn't matter which one. Use whichever one you think, I don't know, would work best for you. So let's get one radical by itself. Let's subtract one of them. So minus square root of x plus 5. What are we left with? We have the square root of x minus 3 is equal to 4 minus the square root of x plus 5. Okay, let's go ahead and square both sides. And we see that square undoes that square, but this square does not undo this square because it also has to do that square. So it actually squares it. We have to go ahead and FOIL. So that we're left with x minus 3 is equal to 4 minus the square root of x plus 5 squared. So let's go ahead and FOIL. So I'm going to actually write out, and we're going to multiply it out. You can use your foiling techniques that we learned in chapter 4 if you'd like. So we have 4 times 4, that's 16. 4 times the square root, we have negative 4 square root of x plus 5. Negative square root times 4, we have negative 4 square root of x plus 5. A negative times a negative is a positive. And then we have the square root of x plus 5 times itself, so it's going to be squared. And on the left-hand side, we have x minus 3. Okay, let's clean this up. So I have 16. I can't do anything with that radical, so I'll just write it down. But we can combine like terms. I got ahead of myself. These two are like radicals, or like terms. So negative 4 minus 4, that gives us negative 8. So I have negative 8 square root of x plus 5. Plus that radical and that square undo each other, we're left with x plus 5. And on the left-hand side, I'm left with x minus 3. Okay, let's go ahead and set it equal to 0. So I have minus x plus 3 plus 3. And we're left with 0 is equal to, we have 16 minus 8 square root of x plus 5. Positive x minus x, that's gone. And 5 plus 3 is 8. Now I can add these up, right? 16 plus 8 gives us 24. Minus 8 square root of x plus 5. All right, our goal here is to go ahead and square that radical. So to do so, let's go ahead and move it to the other side. Let's move plus 8 square root of x plus 5. So that we're left with, this is a lengthy problem, right? It's really testing our algebra. We have 8 square root of x plus 5 equals 24. Let's go ahead and square both sides. Now the square, because it's not being added or subtracted, can actually apply to each one. So that I have 8 squared and the square root of x plus 5 squared is equal to 24 squared. That's a really big number. So let's go ahead and use our calculator. 24 raised to the second power is 576. All right. 8 squared is 64. This square root and that square undo each other, so we're left with just x plus 5 is equal to 576. Let's distribute this 64. So we're left with 64x plus 64 times 5, 320, equals 576. All right, let's go ahead and solve. So minus 320 minus 320. We're left with 6, 5, and 2. 64x is equal to 256. Let's go ahead and use our calculator. 256 divided by 64, we get 4. Whew, so much work. This is definitely the lengthier, more challenging type. This is a lot. If you want to go back to the beginning of this problem, maybe see it a couple more times, I totally encourage that. However, we still have to check our work. So I'll let you do that on your own. For the sake of making this video not too lengthy, I'll let you try this one out yourself. If you're very curious, this is example 7 from your text. Alright, this was section 6.6, solving radical equations. Thank you.